Okay, let's graph two of our other trig functions. Okay, you might want to write down these directions on that same notes that you wrote the directions for tan and cotan yesterday. Okay, they're not hard. They're just very procedural. You have to do one thing first and then a second thing second. Okay, so every time we graph a cosecant or a secant, you are going to not start with graphing cosecant or secant, but you're going to graph his friend, the sine or the cosine. So we're going to get your max value, your min, and your zeros from your sine equation. Okay, so the sine equation that we're going to get our zeros from is sine of 2x plus 1. So notice that is the exact same equation, only with a change of trig. We're using sine because sine is the reciprocal of cosecant, and cosecant is the reciprocal of sine. Okay, so we're going to get all of our points. We're going to get our zeros, our maxes, and our mins from your sine graph, and then we're going to graph our secants based upon those 3 points. Maxes, mins, and zeros. So the sine of 2x plus 1 has a period of 2 pi over 2, which is just pi. Okay, so we come over to our x-axis, and we mark it with pi and with 2 pi. Right, we put 2 complete periods on your x-axis, your horizontal axis. And then hopefully you remember that this plus 1 means we have a vertical shift of 1 unit up. So we come over to our y-axis, we put a 1 tick mark, and you'd put a horizontally dashed line representing your new x-axis, right? This is your zeros will occur there. So now let's graph our sine. Sine, hopefully you remember, starts at the origin, ends at the origin, and has a 0 in the middle. Starts at a 0, ends at a 0, and has a 0 in the middle. Okay? And it also goes up to a maximum, which is 1. So we have 1 unit above your midline in the middle, and we have 1 below the midline in the middle, right? Those are your points for sine. And now we do a second phase or a second period to complete our graph, and even one negative if we have a negative part of your graph on there. Do not leave any part blank. That is not sufficient. So what we need to understand is everywhere that sine has a 0, cosecant has an asymptote. So at all the places where our sine graph crosses your midline, we put in a vertical asymptote. Everywhere sine is 0, cosecant is undefined. So we have a vertical asymptote at all of these zeros. Now, from every minimum value, we're going to draw a downward-facing parabola, right? It's not really a parabola, but it just sort of resembles one. And then we hopefully are pretty familiar with parabolas, so we know that they look like U's and such. So, from the minimum, we draw a downward-facing parabola. From the maximum, we draw an upward-facing parabola. And we always stay in between your asymptotes. Now, I know this isn't part of the problem, but what is your range for our graph? The range goes from the minimum value, which is negative infinity, right? It comes off of down below and stops at 0. And then it jumps up to 2, and then it goes on to infinity. Okay, so if we were going to write the range of our function, that is from parentheses negative infinity to 0 with a bracket, So this is the range, not the period, combined with positive 2 to infinity. So when we're writing ranges, infinities always get parentheses, and your minimum values from your sine and your maximum values from your sine get brackets. So that's how we write the range of our cosecant function. So now let's look at our secant graph. So if we're going to graph a secant, we're going to get all the points from our cosine. So we're going to look at the points from 2 cosine x minus pi over 2 instead, right? This gives us our max, your mins, and your zeros. Because everywhere cosine has a 0, secant has an asymptote. Okay? So we know that the period is going to be 2 pi, right? The period is 2 pi. There is no number in front of x except for a 1. So we have a period of 2 pi. We come over and we write 2 pi, and then a second period puts us at 4 pi. 2 pi and 4 pi. Okay, our cosine has an amplitude of 2, which means we're going to be 2 units above and below our middle. In this case, that's the x-axis. So we come up 2 units on our y-axis and we put a dot, right? That's the max. So graphing cosine, cosine starts at a max and ends at a max. So we put another unit, 2 units above the 2 pi, because that's the end of our period. Halfway, we put a minimum. Right? These are the steps to graphing cosine. And then in the middle of those, we have zeros. And we can continue with another period with the same graphs. Our zeros, your maxes, and your mins. And maybe even one negative. So these are all the dots. These are our maxes, your mins, and your zeros for our cosine graph. So now we're going to do our last thing, and that is incorporate into here our phase shift. We're going to move all of these points pi over 2 units to the right. So looking at my graph, how many spaces am I going to be moving over? If this is 2 pi, this is 1 pi, this is pi over 2. So on the way that I have graphed it, I'm going to be moving each of my points over 1 space, because that's the pi over 2 units. So all of my red dots are going to go over to the right 1 space. So this is how we do a phase shift. The same as with cosine, the same as with sine. All of our points got moved over. Okay, just like with cosecant, everywhere cosine is 0, we put a vertical asymptote. So all the zeros, everywhere the cosine crosses the x-axis, we put a vertical asymptote. And now, from our maxes, we have upward parabolas, and from our minimums, we have downward parabolas. Okay, do your best to hit that max and that min point. If you happen to miss, that's okay. And do your best to keep them evenly spaced horizontally. Okay, it just looks ridiculous if this one is way down here and that one's way up there. Okay, do your best. Now, our last question, what about the range? Okay, I know it's not part of it, but we come from negative infinity and we stop at -2, and then we jump and we start again at +2. So our range would be parentheses negative infinity to -2, bracket, union, +2 to infinity. Okay, secants and cosecants always have a gap in between where the sine and cosine have their range. It's everything but that sine and cosine range. Excellent job. Okay, so when we're graphing secant and cosecant, we want to get the maxes, the mins, and the zeros from your related sine and cosine equation. Okay? Have fun with these. They're pretty okay stuff.